At the end of the first round, here are the scores. Our Lady of Grace Senior High School has 13 points. Presbyterian Boys Secondary School has 16 points. GSTS has 16 points. Round 2. In this round, we have the Truster AI Speed Race. The speed race is sponsored by Truster AI, your real-world experience. In this round, the questions are going to be directed to all 3 schools simultaneously. For an opportunity to answer a question, you must ring for it. May I hear your bell? Thank you. Yours. Thank you. If you ring and answer correctly and it's the first attempt at the question, you get 3 points. If it's the second attempt at the question, you get 2 points. And if it's the third attempt, you get 1 point. However, you should take note. If you attempt to answer a question and you are unsuccessful, you lose a point. When you ring, you will be called upon to answer. Please get straight to the point. If you start with things like, Madam, we have a repetition of the question, you will be bailed out because you have 3 seconds from when you are called to provide an answer. Let's hear the bell, please. May I hear the bell? Thank you. That's the indication. That's the indication that you have been bailed out, and what you are saying is probably the wrong answer, fetching that penalty. For questions that require calculations, you have up to 30 seconds to provide an answer. If there are no calculations, you have 10 seconds to do so. Best wishes, everyone. First set of questions, 30 seconds each. First one. Find the sound intensity 0.50 meter from the center of a 4.0 watt sound source. Yes, file say.
1.0 by 10 raised to an exponent of 2 watts per meter squared.
That's incorrect. I continue. A 4.0 watt sound source emitting sound. Yes, Kekeli.
1.3 watts per meter squared.
You're right. The mass of an object moving along the x-axis changes at a constant rate of negative 0.4 can resume your seats. Okay. The contestants have presented their answers. Before I award the points, let's consider the suggested solution from the consultants. This is a problem from chemistry. So we have been given that there is a borehole in a community that has water, which is highly acidic and contains iron 3 plus ions at a concentration of 1.0 times 10 to the power negative 8 mole per decimeter cubed. The idea is to improve its potability, and so the water is treated with calcium hydroxide to lower the acidity until the pH reaches 10.0. Then we're given that the solubility product of iron 3 hydroxide is 4.0 times 10 to the power negative 38. And the first question was, will iron 3 hydroxide precipitate under these conditions? Let's see how that goes. Okay, in order to be able to do this, first we need to find the pOH, right? So the pOH is 14.0 minus the 10.0 that we've been given, and this gives 4.0. So from there, we can obtain the concentration of OH minus. The concentration of OH minus is going to be 10 to the power negative 4.0, and this is equal to 1.0 times 10 to the power negative 4 mole per decimeter cubed. If you don't give me units, really, I don't know what you are talking about. Okay, we continue from here. If you get this far, 2 points. From the equilibrium reaction, and we can write a reaction here, FeOH3 going reversibly to Fe3 plus 3OH minus. Or if you like, can write the reverse reaction. Anyway, from this, you can calculate what we call a reaction quotient. The reaction quotient Q is given by the concentration of Fe3 plus multiplying the concentration of OH minus, this raised to the power 3, because we are using that balanced equation that we had. If you do this calculation, you will get the reaction quotient to be 1.0 times 10 raised to the power negative 8, multiplying 1.0 times 10 raised to the power negative 4 cubed. And this gives 1.0 times 10 raised to the power negative 20. After you receive this quotient, next is to compare to the solubility product, which has been given for iron 3 hydroxide, right? That is 4.0 times 10 to the power negative 38. So you see immediately that this quotient we have calculated is greater than the solubility product. And because of this relationship, yes, precipitation will occur. All right, for calculating the reaction quotient correctly, 2 points. And then for making that conclusion that precipitation will occur, 1 point. Now, since we know that it will occur, we can continue our questioning. The second part is, if precipitation will occur, how many milligrams will precipitate from a 1.0 decimeter cubed sample of the groundwater? Okay, so here we take the concentration of iron 3 plus at equilibrium to be equal to the KSP, which was given, divided by OH minus raised to the power 3, the concentration of OH minus raised to the power 3. We substitute values that we have already calculated, and we will get 4.0 times 10 to the power negative 26 mole per decimeter cubed. At equilibrium, and this part is very, very important, at equilibrium, only 4.0 times 10 to the power negative 26 mole per decimeter cubed of Fe3 plus can be present in solution. This is a very negligible amount. I hope you agree. Okay? So, in fact, all the ions must precipitate out of solution. If you are able to make this link, 3 points. Then we proceed. The molar mass of FeOH3 is 107 grams per mole. So the mass precipitated is 1.0 times 10 to the power negative 8, which we calculated somewhere before. It was actually given, that part was given to us. Multiplying 1.0, multiplying 107, multiplying the 1,000, the sample, right? And this gives 1.07 times 10 to the power negative 3 milligram. Oh, no. Yes, 1.07 times 10 to the power negative 3 milligram. Then to fulfill all righteousness, because the significant figure matters. So we now will round this off to 1.1 times 10 raised to the power negative 3 milligrams, 2 points, giving a total of 10 points. Okay, now contestants. Our Lady of Grace, you started calculating something. I, in fact, don't understand what you are calculating. And so you were not even able to tell us whether precipitation will occur or not. And so, unfortunately, I can't give you anything. You have 0. Presbyterian boys. Yes, you started well. You calculated the POH. Then you launched into a calculation of some KSP of sorts, right? Unfortunately, it doesn't look recognizable to me what it is you are calculating. However, you were able to make some statements about the precipitation. You say precipitation will occur based on whatever it is you calculated. Okay, I'll give you the 1 point for that. I'm giving you the 2 point. The 2 points earlier on for the calculation of the POH, and then the resulting in the calculation of the concentration of OH minus. So 2 and that. The rest of it, yes, you try to set something up. To be honest, I am not going to accept what you have there. All right. That assumption that you need, that realization that at equilibrium you only have 4.10 raised to the power negative 26 mole per decimeter cubed of Fe3 plus. And so this is a negligible amount. I didn't see you making those conclusions there. There was nothing like that. And so basically, that is what you have. You have 3 out of 10. Do you have a mass of 1.1 times 10 raised to the power negative 3 milligram?
Yes, please.
Sorry.
I will come and take another look. Okay. In the meantime, yes, you calculated for POH, and then you wound up with a value for OH minus, but there is no unit, right? So I can't give you the full 2 points for this. I'm giving you 1. Okay. Then you also do some things, but you decide that, yes, precipitation will occur. You get 1 point for that, and that gives you 2, because the rest of it I'm not accepting. Okay, so you have 2 out of 10. Give me a moment to check what the Presbyterian boys are telling me about their calculation.
It's here.
Where are your assumptions?
1.0 times power negative 3 moles per second.
There are no assumptions. You just jump to that. The best I can do is maybe add 1 point for a final answer. All right, so for the Presbyterian boys, for the final answer, I'll add 1 point, giving them 4 out of 10. That's the end of the problem of the day and the end of round 3.
Yeah. See, no one knows tomorrow. Anything can happen. Once more, yeah, go fit enjoy to sorrow. In such times, we rely on insurance. Charlie, no need to borrow. Make I tell you about this fresh insurance way go be safe tomorrow. Ah, you feel do it with Momo. See, make a krawa. Monthly premium as low as 3 CB. Make a krawa. You can do it on your mobile phone. Easy. Make a krawa. Star 778 hash on MTN. Make a krawa. Covers death policy. Accidental death. Make
Increasing over its domain, or it is decreasing over its domain. Selling them.
Yeah. See, no one knows tomorrow. Anything can happen. Once more, yeah, go fit enjoy.